George and I, we are more or less experts for the water electrolysis. I know that this is only a small part of the whole electrolysis world in chemistry. And in your paper, Chad, you also mention a lot of other chemistry electrolysis, galvanization, and all that stuff. We are experts for the electrolysis of water, and so I wanted to find out what is the current textbook explanation for the electrolysis of water. Here you can see some of my books. This is physics, and these are the chemical books that I reread. I've read them many times over, but I reread them again to find out what really happens. And of course, I also looked a lot in the internet to find the videos and stuff. And the first thing that is obvious is that in the chemistry they very often use formulas. But the formulas do not represent what's really happened, what's really happening. The formula is more a summarize, a summarize of what is really going on. And a better way to find out what is really going on is to look at the molecules itself. And I found at least one video that shows this and a little bit more precisely. And I would like to share that with you and to show you what is my understanding, or what is the current scientific understanding of electrolysis. You can see here water, and there is no KOH in this water, no electrolyte, nothing. It is just water, which is amazing because this video does not explain what the KOH or the NaCl or whatever really does. It is focused on water only. So this can't be the whole story, because we know that we have we put some KOH in the water, the current flows much better than without KOH. But this video does not reflect on electrolytes. It's just the water itself. Now they talk about 4 equations that take place at the same time, four things that happen at the same time. And I will write down them here on the left side as an equation, but I will also use a method to show the molecules and what's happening here. So the first step is on the right side here. This is the anode, the plus pole, the plus with less electrons, and this is the cathode with a lot of electrons. The first thing that happens is that the water molecule on the right side, when they are close to the anode, then suddenly they lose their connection. 2 of them lose their connection to their H, to the hydrogen. 2 of them lose this. So we have 4 hydrogen and 2 oxygen. And so the 4 hydrogen then this happens without any electrons given to the anode, and that is already my first question. How can that happen? But anyway, let's take it the way they say it here. So the 2 water molecules lose their bond to the 4 hydrogen atoms. Now the 2 oxygen go together, and the 4 hydrogen meet another water molecule, and every time, and then this H3O plus ion is being created, and that's the process when they lose one electron here. So the first one does it here, one electron is gone, the second one and the third one are down here, and the fourth one is over here. So I show this whole thing again. So the water suddenly loses their loses their hydrogen, like a car loses its wheels. So then we have 4 hydrogen, and they jump to a water molecule and they form an H3O. So that means when you write it down as a formula, you write down 6 H2O change into an O2, which is a gas, plus 4 H3O plus, and 4 electrons go to the anode. They also kind of move away. So this is the first thing that happens. Now we have the H3O hydroxy. I don't know what's the English name for this. And it's the H3O that now is positive, has a positive charge, and it starts to move to the cathode. So it's a cation now, and it starts to move to the cathode. And that's what they show here. The O2 gets out. The electrons go to the anode, and the 4 H3O plus walk to the opposite side. Now at the same time, what happens on the other side is, you can see it here, an electron, like a torpedo, jumps to one of the water molecules, and it bumps in it. It bumps the water molecule, and the water molecule loses its H again. It's H plus, or I say the H, the hydrogen, and the hydrogen now bonds together to an H2, and the OH minus, which is again an ion, moves to the other side. So which means what happens here is, that the 4 H2O, they get a torpedo electrons, which means that they are being separated, and 2 H2 plus 4 OH minus. When this happens at the anode, this happens at the cathode. When I write this formula, do not reflect what's really happening. So when I write down what's really happening in a different form, I have to write the following. For what happens at the anode, 6 H2O, which is which looks like that. This is O and an H. I will write this down. I will make a break and write this down, so that doesn't take too long, okay? So here you can see the 6 water molecules, and 2 of them now break apart, which I will show you now. Okay, now I think what happens is the following. When they break apart, the 2 water molecules break apart, the following happens. The the covalent bond is gone, and the oxygen takes back their own 2 electrons. So they have again 6, and I guess you know that they have, because they are paramagnetic, they will react to the way that they have single electrons on the outside, and they will react to this. They will go 2 bonds. Oh, you have to write it like that. With their 2 free electrons, they form a double connection, a double bond, and this is the O2 that goes out of the water again. Now the H keeps its electron also, so that they can stabilize their lane. I need to find an English word. I'm sorry. I will call this a trajectory. I hope that is the right word. So the H keeps its own electron on its trajectory, on its S trajectory. That is important. As I read it, the electron, the hydrogen cannot be without an electron, his own electron or the electron of somebody else, because it needs to keep its trajectory in place. So there is no way it can be just a core. This is not possible, and this is not what's really happening. So a single atomic core, or a single H as a core, which is called H plus, that does not exist by its own. It must always have a partner, because it needs to keep its trajectory in a defined state, in a defined state. So what happens now? These 4 H, which is now atomic H, by the way. This is an H atom, hydrogen atom. These hydrogen atom now, they meet the 4 water molecules up there, and when they meet with the water molecules, then something is happening that it must look like that. The O, I'm sorry, I write it a little bit different. O, H, H, H. This is the H3O plus. Now, which is and that happens with 1 electron that is now not needed anymore. The question is, which one is it? Is it the one that the hydrogen has already on his trajectory, or does the oxygen share its electron immediately with the hydrogen? I don't know. But the interesting thing is that I couldn't find anything about it. They always use those formula which do not explain what's really happening here. Anyway, I think this is the way it happens, and yeah, that's the first. That's what happens here. The second one, 4H2 plus 4E minus, looks like that. I will transfer this down here so that I can show you this, the second equation, also in this. It's an electron writing method or whatever. This here. Okay, I do this now. Okay, here's the second equation. the 4 water molecules, they get a torpedo hit by an electron. And what happens with each hit, is the following. The one hydrogen stays the same. The other hydrogen loses its bond, but the electron of it is kept from the oxygen. The oxygen does not give the electron back. So something happens here that is different to the first equation already. Anyway, and the hydrogen now carries an, I guess it's the way, it carries now this electron here. It gets the electron. Maybe it's something like the hydrogen says, okay, I don't care, I take the new one, give it to me, and then I'm free of you, you shitty little oxygen. I don't know how that really works, but the electron is like a torpedo that hits the water molecule, and it splits off the H as an atom again. It is an H atom. Now the oxygen has one electron too much. That's why it's now a negative, why it's an ion. And this happens 4 times. And because this happens 4 times, then the 2 H atoms are recombining to an H molecule, H2 molecule. And this is exactly what George and I don't think that happens. Because is it really true that they can find each other always, just as they show it in this video? I don't think so. But we're talking about what the textbook says. The textbook says the electron is a torpedo that splits a water molecule apart to an OH minus and an H, and this is a real H, and the H now combines to an H2. They can find each other miraculously, and that's it. Okay, now we have ions here in this solution and in the water. And what happens now? When I look at the video, you can see that, I'm sorry, this is again the same thing. Now here comes the torpedoes on the left side. The torpedoes bomb the H2, bombs on the H2O, the water molecule, and it splits to OH minus, and it combines to H2. And the H2 leaves the water. Now, what happens now? The next step is that the H3O plus ions now reached the cathode. And again, they get a torpedo hit, as you can see here. And this torpedo hit makes them water again, as you can see here, plus hydrogen. The hydrogen again combines to a hydrogen molecule, but also here you can see it is an atomic hydrogen. So also the textbook says that hydrogen is being generated in the atomic state. That is very important for us HHO, because that's what we think is happening, that the atomic state of the hydrogen is longer than they expected in the textbook. But the textbook says immediately they recombine to H2 molecule. They call this nascierend. I don't know what's the English word for this. Nascierend. So we will write this down in an equation, and the equation must look like that. So this is the third step that happens here at the cathode. The third step says where is it? Here. The first it says the 4 H3O plus ions get hit by 4 electrons and they get split apart into 2H2, which again leaves the water, and simply 4H2O. Now write this down in electron form. Then I'm here, and I write it down and start over again. So here you can see it, the H3O plus, and I show it with this one here. Now it get hit by the electron, and what happens is that maybe the O2 says okay, maybe the hydrogen says, oh, I take the new guy here, and I'm now an atom again. I'm on my own, and I'm now an atom. I take the new guy, and the oxygen is like, okay, that's it. If you have your own, I go back to water again. Maybe that's what happens. And this, because these are 4 of them, then we of course have then at the end we have 4 molecules, 4 times molecules of that water molecules, and we have 4 times the H atom, and again the H atom goes then to 2H2, to 2 hydrogen molecules. Again, the important thing is that even the textbook tells us that there is an atomic hydrogen available for a very short time, but it is there. It's not that they can deny this. Okay. Now the 4th one is the craziest one, in my opinion. What happens last is the following. As you can see on here on the right side, the OH minus now is close to the anode, and the anode now pulls out somehow. For me it looks a bit like the OH minus starts to shoot on the anode, so they shoot on the anode now. And that makes them lose the H, the hydrogen, and the O2, the oxygen combines to the oxygen atom combines to an oxygen molecule immediately. Let's write that down in a formula. So we have the 4 OH minus, they are now recombined to H2 plus 2H2O plus the 4 electrons that leave that go into the anode. Now how does that look like? As you can see, the OH here suddenly, miraculously, starts to shoot its electron to the anode. Well, I write this down again as an electronic picture, or I don't know what's the English word for this. Elektronenkonfiguration, the electron configuration picture, or whatever. Here you can see the OH minus. The question whether this is right is this really right? Because because they have 2 electrons, 4, 6, and they share 2 of them, which is 8 electrons. Maybe this is not right. What happens is it shoots away an electron, or the electron is drawn away from the anode. And I guess what happens is that the O goes back to the state it was. Yeah. This electron here, this line means 2 electrons. 1 electron goes away together with the H, so the H again has 1 electron. I said it is important that it keeps its trajectory, and I guess then this is the electron that goes away. So after this we have again O in the usual way, and the 2 O combine then to OH2. 2 of them combine to O2. Oxygen atom, 2 oxygen atoms combine to an oxygen molecule. And now something very interesting happens. The H here does not combine to another H. As you can see it here, there are 2 H. Why they don't combine to each other and leave the water just the way they do it at the cathode? At the anode, it's not that the H2 combines, but what happens is that the H2, that the hydrogen now combines with another OH minus, as you can see here. There it is, with another OH minus by losing another electron. So we have two electron torpedoes. The first torpedo goes from the OH minus directly to the anode, so that O2 is being produced. And when the lost hydrogen meets another OH2, they shoot a second time. Here, they shoot a second time, as you can see here. And then the whole process is over. Which means that we have there 2 steps. One is this, and the second one is, so I call this here A. And the second one now is that we have this H atom, we have our OH minus, this is the OH minus, and now the OH minus, which has 2 electrons here, they combine and then they lose 1 electron. So which one do they lose? Is it this one? Is it this one? Is it this one? I don't know. It's not explained somewhere. I don't know which one they lose, but they lose 1 electron, because then it's again the good old H water molecule. So this goes into the water molecule by losing 1 of the electrons. I don't know which one it is. I guess it's the one of the hydrogen, but it's the hydrogen electron here is on the S trajectory, which is the smallest trajectory. Anyway, so this is what I found out from the textbooks, and yeah, I think that it took me quite a while to find all this out, and there are a lot of questions to be asked. But in this video, I just wanted to make sure that we have a common understanding of the textbook opinion, the scientific opinion of what water electrolysis is doing, and how that really happens. Good. I think that's enough, and yeah, I hope that I helped you with this a little bit. And there are a lot of questions to be asked, and I will do this in another video. I will not do, this is the opinion of the textbook, and I hope that every guy we can meet who has knowledge about chemistry, who can tell us, okay, what you say here is right. That's the way we understand electrolysis of water. So there's no funny stuff here. It's just the opinion of the actual scientific opinion of everyone, how that really works. Good. Bye-bye then.